All right, let's dive right in. We're going to tackle a puzzle today. And it might seem simple at first, just a couple of boats on a lake, but trust me, the solution is going to take us all the way out to the stars and completely change how you look at the night sky. Pretty cool, right? So picture this. You've got a rowboat just kind of chugging along across a lake, and then a yacht comes zipping across its path. The question seems super straightforward, doesn't it? Where did that yacht cast off from?
Okay, so your gut reaction, like mine, is probably to say, well, duh, it's point M, right? It just makes logical sense. You see the path, you follow it back, boom, there's your starting point. And you know what? If you were standing on the shore, you'd be 100% correct. But that is not the whole story.
This is where things get interesting. What if we switch things up? What if you're not on the shore anymore? Imagine you are actually in that little rowboat. Suddenly, from your point of view, the world looks totally different. And the answer to our simple little question? Yeah, it changes completely.
So check this out. We've got two totally conflicting realities happening at the same time. The person on the shore who's standing still sees the yacht start at point M, but the folks in the rowboat, they'd swear on a stack of Bibles it started way over at point N. So what gives? How can they both be right?
And this, right here, is the absolute heart of the puzzle. The people in the rowboat, they don't feel like they're moving at all. To them, it feels like they are the fixed, stationary center of their world, and everything else, the shore, the trees, the yacht, is what's actually moving. Okay, let's really break down this illusion they're experiencing. First off, they feel completely still. And second, as they're moving forward, it looks like the whole world is just sliding backward, right? So what they end up seeing is a mashup of two different things. The yacht's actual movement, plus this kind of ghost motion of the world drifting past them. So the big question is, how do we actually combine these two different movements to see exactly what the rowboat crew is seeing? Well, lucky for us, physics has this really elegant, almost beautiful tool for solving this exact kind of problem. It's called the Parallelogram of Velocities. I know, that sounds super technical and maybe a little intimidating, but don't worry, it's basically just a fancy name for a really simple drawing trick. It helps us add two motions together to see what the final combined motion looks like. Let's just build one together, step by step. It's easy. Okay, step one. Let's just draw the yacht's real motion, the one you'd see from the shore. We'll use an arrow for this. In physics, we call that a vector. This arrow, let's label it B, shows the yacht's actual speed and direction. Simple enough. All right, step two. Now we need to add that ghost motion we talked about. Remember, this is the illusion created because the rowboat itself is moving. So we're going to draw another arrow, another vector. We'll call it negative A. It's the same speed as the rowboat, but it points in the exact opposite direction. And for the grand finale, step three, we just connect the lines to complete the shape, a parallelogram. And then we draw a line right through the middle, the diagonal. And would you look at that? That diagonal line, that's it. That's the path the yacht seems to be taking from the rowboat's point of view. It perfectly explains why they're so sure it started all the way back at point N. And this is the moment where this simple little boat puzzle gets huge. Because, as you've probably guessed, this was never really about boats on a lake. It's a perfect analogy for something much, much bigger. Our own place in the universe. Just think about it for a second. That little rowboat, that's us. That's planet Earth, whipping through space at incredible speeds. And the yacht, that's a distant star. The lake itself, well, that's the vastness of our solar system. We are, quite literally, the crew in the moving boat. You see, what we've just worked through is a real, honest-to-goodness astronomical phenomenon. It's called stellar aberration. And it's the idea that because our planet is constantly in motion, we actually see stars in slightly different positions than where they truly are. It's the exact same principle as the rowboat crew seeing the yacht start from the wrong spot. So you might be thinking, okay, if that's true, why don't I see the stars wobbling all over the sky every night? And that's a great question. It's because the speed of light from those stars is just so much faster than the Earth's speed. We're talking roughly 10,000 times faster. So the effect is super tiny. But, and this is the amazing part, with our modern telescopes, it's not just detectable, it's perfectly measurable. All right, so now you get it. You've seen how this one simple idea of perspective connects a boat on a lake to a star in a distant galaxy. So, I think you're ready. It's your turn to solve a puzzle. Let's totally flip the script here. Now, I want you to imagine you're on the yacht. From your new perspective, what direction does it look like the rowboat is moving? Think about it. Think about the yacht's own movement and the kind of illusion that would create. And for your final challenge, the big one, where do the people on the yacht think the rowboat is actually going? What's its destination from their point of view? I'll give you a little hint. The answer is hiding inside a brand new parallelogram, just waiting for you to draw it. You know, when you boil it all down, it really is all about perspective. I mean, if our own silent, unfelt journey through space can literally change the position of the stars in the sky, it really makes you wonder, doesn't it? What else are we missing? What other fundamental truths might look completely different if we could just, for a moment, change our point of view?